In this video, I am going to discuss LC circuit synthesis problem using the second Foster form. In the previous video, I discussed the same example using the first Foster form. Both the Foster forms we used partial fraction expansion to find what are the components in the circuit. In first Foster form, we use partial fraction expansion for the given impedance function, and also in second Foster form, we are using partial fraction expansion for the admittance function. In this example, the impedance function is given ZLC S is equal to, in the numerator, s to the power 2 times s to the power 2 plus 2 times s to the power 2 plus 4, and the denominator is times s squared plus 1 into s squared plus 3. Now we have to simplify the equation, and we can cut one s here. Then we can write the impedance function again. ZLC is equal to s times s squared plus 2 s squared plus 4. That is the numerator, and the denominator s squared plus 1 s squared plus 3. This is the simplified function, the impedance function. In the second Foster form, we have to apply partial fraction expansion for the admittance function. Then we have to find the YLC admittance function. It is 1 over ZLC. Then we can change the numerator and denominator. We can write s squared plus 1 s squared plus 3 over this time s squared plus 2 s squared plus 4. That is the admittance function. Now we have to apply the partial fraction expansion for this function. If we consider the maximum power of s in numerator, it is 4, and the maximum power of the s in denominator is 5. We can find poles of the function using roots of this denominator. S is equal to 0, and s squared plus 2 is equal to 0, and s squared plus 4 is equal to 0. From those parts, we can find the roots. Now I will write the partial fraction expansion of this admittance function. YLC is equal to s squared plus 1 s squared plus 3 over s times s squared plus 2 s squared plus 4. And we can write the partial fraction expansion a over s, the first root, plus bs plus c over s squared plus 2, the second term, plus ds plus e over s squared plus 4. Now we have to find the what are the values of a, b, c, d, and e. I will expand the numerator side of the left hand side. It is equal to s to the power 4 plus 4s squared plus 3. It is equal to a times s squared plus 2 times s squared plus 4 plus bs plus c into s into s squared plus 4 plus ds plus e into s into s squared plus 2. This is the expansion, left hand side and right hand side. I rewrite it again, s to the power 4 plus 4 s squared plus 3 is equal to a into s to the power 4 plus 6 s squared plus 8 plus bs plus c s into s to the power 2 s cube plus 4s plus ds plus e s into s to the power 2 plus 2 s cube plus 2s. Now we have to find the what are the value for a, b, c, d, and e. First, I consider the s to the power 4. S to the power 4. From the left hand side, value is 1. And from the right hand side, we can see a into s to the power 4, a, and bs into s to the power 3 is b times s to the power 4. Then b. And here also there is a s to the power 4 term, ds into s cube, then d. I name that equation as first equation. Then I consider s to the power 3 values. From the left hand side, no any s to the power 3 values. And from right hand side, c into s cube, c plus e into s cube plus e. This is second equation. And now I consider s to the power 2. From the left hand side, value is 4. From the right hand side, a into 6 s squared, 6a, bs into 4s plus 4 into b plus ds into 2s is 2d. This is third equation. And now I consider s to the power 1. From the left hand side, there are no any terms, 0. From the right hand side, c into 4s, 4c plus e into 2s, 2e. This is my fourth equation. Then finally, s to the power 0, that is constant terms. From the left hand side, the value is equal to 3. And from the right hand side, a into 8, 8a. From this equation, I name it as 5. We can get the value of a. It is equal to 3 over 8. Now we know the value of a. It is 3 over 8. And now I consider second equation and fourth equation. From second and fourth, 0 is equal to c plus e and 0 is equal to 4c plus 2e. Then from these two, we can write c is equal to 0 and e is equal to 0. Now we have to find the value of b and d. Now we know the value of a. Value of a is equal to 3 over 8. I am using first equation. It is equal to 1 is equal to a plus b plus d. Now we know the value of a. Then we can write 3 over 8 plus b plus d is equal to 1. From this equation, we can get a value for d. 1 minus 3 over 8 minus b is the value of d. We can simplify it. 5 over 8 minus b is the value of d. I name it as star equation. Then we can apply this value of d to the third equation. From third equation, 4 is equal to 6a plus 4b plus 2d. 4 is equal to 6 times 3 over 8. Value of a is 3 over 8 plus 4b plus 2 times 5 over 8 minus b. Value of d is equal to 5 over 8 minus b. Then we can write 4 is equal to 6 into 3 is 18 over 8 plus 4b plus 10 over 8, 2 into 5 over 8 minus 2b. From this one, 4 is equal to 18 plus 10, 28 over 8 plus 4 minus 2 plus 2b. Then 4 minus 28 over 8 is equal to 2b. We can write 32 minus 28 over 8 is equal to 2b. 32 minus 28 is 4 over 8 into 2b. From this one, we can write b is equal to 1 over 4. Then, using this equation, we can derive the value of d. D is equal to 5 over 8 minus b. We can assign value of b is here 5 over 8 minus 1 over 4. It is equal to 3 over 8. Now these are the value for, this is value of A, 3 over 8. Value of B is 1 over 4. And value of D is 3 over 8. And C and E are 0. Now we can write the expansion YLC is equal to 3 over 8 over S plus 1 over 4 times S over S squared plus 2 plus 3 over 8 S squared plus 4. This is a partial fraction expansion of the admittance function. These are the small admittance values y1, y2, and y3. Now we have to find the what are the components represented by each and every admittance component. Now I will consider y1 first. It is equal to 3 over 8 over S. I can rearrange it 1 over S times 8 over 3. Then if this is the LC network, if we consider capacitor and inductor in frequency domain, impedance of the inductor is SL, admittance of the inductor is 1 over SL. And if we consider a capacitor, impedance of the capacitor is 1 over CS, and the admittance of the capacitor is CS. If we check the representation of the Y1, it is similar to the admittance of an inductor. Then this is representation of inductor. L1 value is 8 over 3 Henry value. Y1 is represent a inductor. Then I consider the second admittance value. It is S over 4 times S squared plus 2. We can't easily find the what are the components represented by this term. Then I consider the impedance value. Z2 is 1 over Y2. It is equal to 4S squared plus 8 over S. Then we can divide into 2. 1S will cancel, 4S plus 8 over S. I rearrange this part, 4S plus 1 over S times 1 over 8. These two are similar. Then if we consider the representation of this impedance, this is impedance value, ZA, I name as ZA. If we check these impedance values, it is similar to a inductor. And value of inductor is 4 Henry. And if we check this impedance value, I named it as ZB. It is similar to impedance of the capacitor. And capacitor value is 1 over 8. farad. The combination of the inductor and the capacitor is represented by the Z2, and these two are combined with plus mark. That means they are connected in series. Inductor and capacitor. L2 is 4 Henry and I name it as C2. It is equal to 1 over 8 farad. This is the representation of this Y2. Now I will consider the last part. This is Y3. Y3 is equal to 3s over 8 times s squared plus 4. If we check this equation, we can't easily find what are the components represented by this one. Then same as previous Y2, I consider Z3. It is 1 over Y3. It is equal to 8s squared plus 32 over 3s. Then I will divide into two parts. 8 over 3s plus 32 over 3s. I will rearrange this one. 8 over 3s plus 1 over s times 3 over 32. If we check the impedance value of capacitor and inductor, this one represents a inductor L times S. L3 is equal to 8 over 3 Henry. And if we check this one, it is a capacitor C into S. C3 is equal to 3 over 32 farad. And these two impedance values are connected with plus mark, then that means they are connected in series. L3 is equal to 8 over 3 Henry and C3 is equal to 3 over 32 farad. This is the representation of Y3. And if we consider the total admittance, Y1, combination of Y1, Y2 and Y3, they are connected with plus marks. That means they are connected in parallel connection. Then we can draw the final circuit. The first element is inductor 8 over 3 Henry, and Y2 is a combination of inductor and capacitor. The last element also combination of inductor and capacitor. Values are L2 is 4 Henry, C2 is 1 over 8 farad, and L3 is 8 over 3 Henry, and C3 is 3 over 32 farad. This is the representation of LC circuit when we apply the second Foster form. And we can get the admittance value from these 2 points. That is all about that example. Thank you.